Hello students, continuing with the previous video. So now we discuss numerical solution of algebraic and transcendental equations. So the following are the numerical methods to find the roots of the equation f of x equal to 0. The first method is Newton-Raphson method and the second one is Regula-Falsi method. Okay, so in the previous video we discussed so in what cases we apply the numerical methods to find the solution of algebraic or polynomial and transcendental equations. That all we discussed in the previous video. Now we discussed the first numerical method called Newton-Raphson method. Okay, let f of x equal to 0 be the given equation. Then the first approximation to the root is given by x1 equal to x naught minus f of x naught divided by f dash of x naught. So this is the formula which gives the first approximation. So this x1 represents the first approximation to the root. Okay, this represents the first approximation of the equation f of x equal to 0, and here this x naught in the formula is the appropriate root which is to be assumed. So this x naught we are assuming the value of the function at this root is nearer to 0. We follow this condition to choose the value of x naught. Okay. So okay, I explain so how we are choosing the value of x naught. So as we discussed in the previous video, the first to apply this Newton-Raphson method, we first apply the fundamental property. Okay, the fundamental property is what? We are going to substitute the values of x as 0, 1, 2, 3, 4 and all. For one value of x, the value of the function is negative. The other value of x, the value of the function must be positive. The one value negative, the other value must be positive. Then the interval is 1 and 2. So here suppose this 1 and 2 is an interval where a equal to 1 and b equal to 2. From these values of a and b, the one we have to choose as a x naught. The one value we have to choose as a x naught. So here x naught we have to choose as the condition given here. The value of the function at this root is nearer to 0. That means suppose at x equal to 1 the value must be negative. Okay, suppose the negative value is minus 0.25. At x equal to 2 the value of the function must be positive. The positive value I take as a 0.512 something. Okay, approximate something like 0.512. Okay, the one value is negative, the one value is positive, therefore the interval is 1 and 2. From these 1 and 2 we have to choose the one value as a x naught such that the value of the function must be nearer to 0. See, this is 0 here, 0.5 comes somewhere here, then minus 0.25. So this minus 0.25 is nearer to 0. So this is very near, okay, compared to this 0.5. So therefore, so the value which is nearer to 0, then take that value as a x naught. So at x equal to 1, the value of the function is nearer to 0. Therefore, we choose x naught equal to 1. Okay. One way, if you take the x naught equal to 2, you get the answer, but the difference is moving from this distance to this and moving from this to this. The difference is the number of approximations, the number of steps will be more in this when you take x not equal to 2. The number of steps will be less when you take x not equal to 1. Okay, this is the difference. Now, so this is what we call as a first approximation. Okay, now the second approximation, similarly starting with the x1, means we use this x1 is still better approximation. X2 is given by, here it is, x2 is given by in terms of x1, that is x1 minus f of x1 divided by f dash of x1, the derivative of that function f. Okay, f dash of x1. Like that, to find x3 we use x2, that is x3 equal to x2 minus f of x2 divided by f dash of x2. Like that we continue to get a better approximation. So this is the general formula, xn plus 1 equal to, this must be in terms of xn minus f of xn divided by f dash of xn. So this is known as a Newton-Raphson formula. Okay, now we take the problems and we find the value of the x using Newton-Raphson method. Okay, now here is one example. The function is 3x equal to cos x plus 1. We find the root of this equation using Newton-Raphson method. Okay, first we consider this, the function f of x equal to 3x minus cos x minus 1. This is the given function, 3x minus cos x minus 1. Okay, now as it is told, we start finding the value of the function starting from 0, put x equal to 0, and here the one point you please remember, whenever the given function containing the trigonometric function, okay, remember, when the equation containing the trigonometric function, set your calculator to radians, and then continue the process. After setting to the radians, we put first x equal to 0. When x equal to 0, the value of the function we get negative, that is minus 2. When you put x equal to 1, here we have the positive value, that is 1.4597. At x equal to 0 we have negative, at x equal to 1 we have positive value. Okay, so therefore this sentence we must write, the root lies between, the root of this equation, the value of this x lies between 0 and 1. Okay, between 0 and 1 it lies, but from these two we have to choose one value as a x naught. Okay, either we have to take 0 or 1, but f of f1 is nearer to 0. So when you compare this 1.4597 and minus 2, so this value is near to 0. So therefore we take x naught equal to 1. So now, as in the formula, we need the derivative f dash. So we differentiate the given function. Differentiation of 3x is 3. Differentiation of minus cos x is plus sin x. Differentiation of minus 1 is 0. Okay, so this is our f dash. Now we write the formula. General formula is xn plus 1 equal to xn minus f of xn divided by f dash of x1. We take the first approximation. This is called the first approximation x1. Okay, so means when n equal to 0, it is in terms of x naught minus f of x naught divided by f dash of x naught. Now instead of substituting the values of x naught and f of x naught, f dash of x naught directly, here I suggest one point. Keeping this x naught minus, what is f of x? 3x minus cos x minus 1. Take x equal to x naught in this, 3x naught minus cos x naught minus 1 divided by f dash of x is 3 plus sin x. Taking here also x equal to x naught, 3 plus sin x naught. Okay, So in this, I took or else keep this only, this step only, no need to take the LCM, keeping this term. Now we have to put x equal to x naught. Okay, putting x naught is 1. Putting x naught we have to calculate, right? So here I suggest one simple technique to calculate x1, then the next second approximation x2, x3, x4. You can calculate many number of approximations using this technique. Okay, so here the technique is we are going to type this whole equation in the calculator, the whole equation, that is x naught minus 3x naught minus cos x naught minus 1 divided by 3 plus sin x naught. So this we are going to type in the calculator. So this will help you to calculate many number of approximations within a short of time. The one point we have to observe before typing in the calculator, see how we have to take the terms in the calculator. We have this as a equation. Okay, this is the equation. So how we have to consider, first we take this x instead of x naught, taking x in the calculator, first term, then minus, right? Then we have the second term, we have both numerator and denominator. For the second term you type bracket in the calculator, then take the bracket for the numerator, take the bracket for the numerator, right? So this bracket is for second term and this bracket is for the numerator. Type 3 and x minus type cos x minus 1. So this I completed for the numerator, then divided by, take the one more, open the one more bracket for the denominator, that is 3 plus, then we have sin x. This completed the bracket for the denominator, and here we opened for the second term, and here you complete. So this is the way we have to type in the calculator. Once we type properly, then it is very easy to calculate very within a short of time many number of approximation. This is the one good technique. Okay, so understand, this is the first term minus, I took the bracket for the second term, here I opened, here I closed. So for the numerator one bracket, right, divided by, there is another bracket for the denominator. This is the way we have to type in the calculator, right? Now by typing in that way, you have to use the calc button. Okay, here I type, let's just I will show for one problem how we have to type, and very easily you can calculate. See, first you have to set, as we have the trigonometric function, set your calculator to radians. We have here in terms of degree. First I am setting to the radians. So for our radian, that is a radian, we have a 2. Now we set it to the radians. Now we type the equation. So x, pink alpha, and here x, then minus, open one bracket, and this bracket for the numerator, and typing 3x minus cos x minus 1, complete the bracket. Here I suggest you better write in a paper, so that seeing that you can type in the calculator, so that you will not get any wrong while typing. If you miss any one bracket, you will get a wrong answer, that you please remember. Then this divided by, open the bracket for the denominator, then we have 3 plus sin x, 3 plus sin x, then this I completed the bracket for the denominator and this bracket for the second term. Yes, this is the way we have to type in the calculator. Now calc button, right? First, now it is very easy for continuing the many number of approximations. What we have to substitute x naught, so our x naught is 1, so put x naught as 1, okay, press equal. So we are getting many number of decimal 9 decimal places. So in the say do not press any other button, go to mode, fix to 4 decimal places. Okay, we have 0.6200, so very easily we can get. Then while writing the second approximation, we have to write this formula. Don't write directly all the values continuously, taking x2 in terms of x1 minus f of x1 divided by f dash of x1, then substitute f of x1 3x1 minus cos x1 minus 1, then this divided by 3 plus sin x1. This step you have to write, and then you take the calculator, press calc button. Now our x value is 0.62. We have to substitute x1 is 0.62. Putting 0.62, see how easily we got 0.6071. Then this we continue for the third approximation, right? So third approximation x3, writing in terms of x2. Similarly we write all these steps. Now take the calc button, the previous value x2 is 0.6071, 0.6071. So here we got again 0.607. When the value repeats, we have to stop the iterations. Remember that point. When the value repeats, so that you have to stop. Suppose the value is not repeating, right? In that case, how many approximations you have to continue? So sometimes in the problem it will be given like up to third approximation or up to fourth approximation you have to calculate. Okay, similarly you have to try some other problems. Now that one the one problem where, see, using Newton-Raphson method, find a root of the equation x sin x plus cos x equal to 0, which is near to x equal to pi. Correct to 3 decimal places. See, the given function is x sin x plus cos x, then f dash is becomes x cos x, and here we have to find the root of this equation, and the root is near to pi. Near to pi means we have to take this x naught as a pi. In this case, no need to apply the fundamental property. Taking directly this value x naught as a pi, you have to continue the approximations. And also, as I suggested, you type the equation in the calculator as I suggested, taking the bracket for the second term, then bracket for the numerator, then bracket for the denominator. Likewise, you type in the calculator and continue the number of approximations. Okay, the similar type of problems are there, so you continue that. And the one more type is like evaluate square root of 28 to 4 decimal places by Newton's iterative method. So this square root of 28 easily we can find in the calculator, but using the numerical method we have to find out. That is, we take x value, x equal to square root of 28 means we have to find out the value of x. So this we can write as x square minus 28, squaring on both sides, right? We get x square minus 28. So our function is f of x equal to x square minus 28. So f dash is 2x. Okay, we have to start from 0, 1, 2, 3 like that. So here it is calculated. See, at x equal to 5 we have a negative, at x equal to 6 we have a positive, therefore the interval is, the root lies between 5 and 6. So here we take x naught as 5 and we continue the approximations. Yeah, this is the one more type of problem. Okay, thank you.